Hello students, welcome to our third lesson under the subtopic Electron Configuration. Electron configurations come from the word electron, so it is the arrangement of the electrons. Electrons are found in the energy levels or the orbitals, or what we call the shells. An energy level is a fixed region surrounding the nucleus of an atom occupied by an electron of the same energy. By convention, energy levels are named as 1, 2, 3 outwards from the region nearest to the nucleus. Each energy level is occupied by a fixed number of electrons. For instance, the first energy level is occupied by a maximum of 2 electrons, while the second energy level is occupied by a maximum of 8 electrons. Third energy level is occupied by a maximum of 8 electrons or 18 electrons if available. So it is good to note that the first energy level is nearer to the nucleus, followed by the second energy level, then the third. Then the fourth energy level is occupied by a maximum of 8 electrons or 18 or 32 electrons if available. The distribution of electrons in the energy levels of an atom is referred to as electron arrangement or electron configuration. So the arrangement, how they are going to be arranged in those energy levels. This can be presented as 2 for helium, as 2.1 for lithium, 2.8 for neon. Electron arrangement may also be presented by a diagram in which electrons are represented by cross or dot as shown below. So we have helium and we have magnesium. We have the center, which is the nucleus, then we have the first energy level, then we have the 2 electrons in the first energy level. When you come to the magnesium, we have this is the nucleus, then you have the first energy level, then we have the second energy level, and then we have the third energy level. How are they going to be arranged? So the first one will carry a maximum of 2, the second one will carry a maximum of 8, so we have 8, this being a total of 10, 2 plus 8 you get 10. So for magnesium, which is number 12, we'll still have 2 more which will occupy the third energy level. So in this case, it will be found that magnesium has 3 energy level, meaning it belongs to period 3 of the periodic table. It has 2 valence electrons in the outermost energy level, hence it is in group 2. Helium is also in group 2 because it has 2 electrons in the outermost energy level known as valence electron. It has 1 period or 1 energy level, so it is in period 1. That is the arrangement. The atomic radius for this, you'll find that helium has a smaller atomic radius compared to magnesium. So the number of energy levels also increases the atomic radius of that element. Electron arrangement of the first 20 elements, the elements with the same number of occupied by energy level belongs to the same period. For example, we have period 1, we have hydrogen and helium, so they have only 1 energy level. In period 2, we have radium, barium, boron, carbon, nitrogen, oxygen, fluorine, and neon. These ones, they have 2 energy levels, and the third will contain 3 energy levels. So the number of electrons in the outermost energy level of an element determines the group to which the element is in the periodic table. For example, if you have hydrogen, it is in group 1, magnesium group 2, boron group 3, carbon group 4, meaning in boron we have 3 electrons in the outermost energy level. For carbon we have 4, nitrogen we have 5, then oxygen we have 6 valence electron, or the electrons in the outermost energy level, while in argon we have 8. This information can be merged in a grid, the resulting figure in a periodic table of the element. So periodic table is a horizontal and vertical arrangement of elements according to the atomic numbers in a tabular form. So let's see how this is done. Horizontal arrangement forms the period. These are the horizontal arrangement, they form the period, and then we have the vertical, which forms the group. So we have group 1, group 2, and it is good and important to note that they are usually written in Roman numbers. We have Roman 1, Roman 2, 3, 4, 5, 6, 7, and 8. Atoms in the same period have the same number of energy levels in their electronic structure. The number of energy levels in electronic configuration of element determine the period to which the element is in the periodic table, like the one shown above. So hydrogen and helium belong to the same period, while potassium and calcium belong to the same period. So they have 4 energy levels, with the first one carrying a maximum of 2, the other one carrying 8, the other one carrying 2, to make 20 number of electrons. The vertical arrangement of elements form the group, and they are usually in Romans. The number of electrons in the outermost energy level. Here is a periodic table, and we have explained, and in between here we have the transition metals, and we mostly concentrate with the first 20 elements of the periodic table. Here the assignment for you: make sure you understand and work them out. Try to relate what you have learned with these. Thank you and wish you the best.